task here is going to have mixed practice chemical reactions. So what we're going to encounter is either going to be synthesis, where things are put together, decomposition, where a compound is broken apart, single replacement, where one element comes along and replaces another element in a compound, double replacement, in which two cations in ionic compounds are going to switch places, or finally combustion. And if this is the first video you're watching about predicting products, you want to go back and make sure you watch the videos about the individual types before you consider mixed practice. So number 1 here, we have Na sodium plus zinc oxide. I'm going to do a little thinking here. I know that Na is an element, and I know that ZNO is a compound. So this is making me think single replacement as a possibility. Now, Na is specifically a metal element, so I'm going to look in my compound for the metal that sodium would try to replace. That's going to be zinc. So my question is, sodium active enough to replace zinc? What I would check for is my activity series. Now, I don't have one pulled up right here, but if you check your notes, your packet for your activity series, what you'll see is that sodium is up at the top, and then further down is zinc. So this tells me that yes, zinc is lower than sodium, less active, and sodium will be able to replace zinc in this compound. So that's what's going to happen here. Sodium is going to kick out zinc, and so I'm going to get sodium and oxygen together. That's not complete. I will come back and revisit that compound, but I'm going to leave it right there for now. And then zinc is going to get kicked out. I like to say that it got dumped, and it's now alone as an element. Now, before we can balance this equation, we need to look back at this NaO compound. I'm going to do a little notes off to the side and consider the charges so that we can crisscross them. So Na sodium, we know, has a charge of +1. Zn zinc has a charge of +2. So crisscrossing those charges, very important. I see that Na is going to have a 2 on it. So Na2, right here where I'm circling, Na2O is the formula for that compound. So we have finished writing the equation, and now we need to balance it. I'm going to balance it in a different color, pink. I will start by looking at sodium. Sodium has 1 on the reactant side and 2 on the product side. 1 and 2. So I need to multiply by 2 on the reactant side with a coefficient of 2 so that I have 2 and 2 sodiums. All right. Next up, I could look at zinc. Zinc, my other metal, has 1 and 1. 1 zinc here, 1 zinc here. That gets a check mark. That's balanced. And finally, oxygen. Oxygen has 1 here, 1 here. Oxygen has 1 and 1. That's balanced. So my equation here is done. This is my balanced chemical equation for the single replacement between sodium and zinc oxide. Let's look at number 2. Number 2 says Mg3P2. This is all it tells me for my reactants. I don't have any other chemicals being added in. So this is making me think that this is a decomposition reaction. Really, nothing else can possibly happen. If you have one compound and nothing else, the only thing it can do is break down. So it's going to break down into its 2 elements, Mg and P. When you have single elements like this, you ask yourself, are any of these elements diatomic? Remember, that's like O2, N2, F2. Well, Mg and P are not diatomic elements, so we do not need to add any subscripts. All I need to do here is balance. This one turns out to be pretty easy. Because I have 3 magnesiums, I simply need to put a 3 in front of the magnesium on the product side. And I have 2 phosphorus, so I need to put a 2 in front of the phosphorus on the product side, and I'm done. So this was one compound breaking into 2 smaller things. That means it is decomposition. All right, next up, I have C4H18 plus oxygen. This should look familiar as a very specific type of reaction called combustion. Combustion reactions always produce the same products, carbon dioxide and water. All right, so I balance them in the order CHO. My carbon starts with 4, so I need to put a 4 in front of the carbon dioxide to balance it. So 4 to start, but only a 1 over here. Put a 4 in front of the CO2 because 1 times 4 equals 4. Carbon dioxide is balanced. Next up is hydrogen. Hydrogen starts with 8, but it ends with only 2. So what do I need to put in front of water so that multiplied by 2, I'll have 8 hydrogens? I need to put a 4 right here. So let's work on our count. Hydrogen had 8, but ended with only 2. I need to multiply by 4 on the product side because times 4 for hydrogen would give me 8. 8 and 8 is balanced. All right, finally, I'm going to look at my oxygens. My oxygens start with 2, but then I have oxygen in 2 places on the product side. I'm going to highlight them in blue just like before. I have 4 times O2, so that would be 8 oxygens in that compound. And then I also have 4 times O, that's 4 more oxygens. So I have a total of 12 oxygens. So what do I need to multiply on the reactant side to make it equal 12? I need to multiply by 6. So a coefficient of 6 will do the trick. And everything is now balanced. So here is my balanced chemical equation for the combustion of C4H8. All right, let's do another one. This one has Li3PO4, that's lithium phosphate, and CaNO3, that's calcium nitrate. Well, what I'm noticing here is these are both ionic compounds with positive and negative ions. If you have 2 ionic compounds, this is going to be double replacement. To do double replacement, we are going to swap the positive ions. Down below here, I'm going to do the grid like we did in the double replacement video. So lithium phosphate, I'm going to write it, the ions on the top part of the grid. So lithium and phosphate, and then I'm going to make sure I put in their charges. Lithium is +1, phosphate is -3. On the bottom, I'm going to put the ions for calcium and nitrate. Calcium is Ca+2, nitrate is NO3 -1. Okay, to figure out my products, I am going to do the diagonal combinations. That's how I swap the ions. So my first product is going to be lithium with a +1 charge and nitrate with a -1 charge. Those charges will cancel to give me LiNO3. Now, on double replacement, we usually are going to be looking to see if it's aqueous or insoluble. In this case, lithium nitrate, if you look it up on the solubility chart, is aqueous. Let me see if I can find that really quick. I have it right here, the solubility chart. Okay, so I was looking at lithium nitrate. I'm going to highlight. Nitrate is right here. It is soluble with no exceptions. So lithium nitrate is definitely soluble, and we label it with an AQ. My other diagonal combination is going to be calcium with a +2 charge and phosphate with a -3 charge. If I crisscross those charges, I'm going to get Ca3 from the phosphate. Phosphate PO4 is going to be in parentheses, and it's going to get a 2 from the calcium. All right. Now, I'm going to go back and check my solubility chart to see if calcium phosphate is soluble or not. I'm going to look for, remember, my negative ion phosphate. Okay. I'm going to highlight this in purple, a little bit different. Okay. Phosphate is down here at the bottom. Phosphate is insoluble, meaning that it's going to be a solid precipitate unless calcium is an exception. Well, exceptions are ammonium NH4 and alkali metals. Calcium is not an alkali group 1 metal, so calcium phosphate is an insoluble solid product. So I am going to label it with an S. All right. The last thing we need to do here is to consider if it's balanced or not. I have a feeling it's probably not. So let's balance this equation. We're going to start with our metals because that's kind of our order that we do things. If you remember Minho, we do metals, polyatomic ions, nonmetals, hydrogen and oxygen last. So I'm going to look at lithium first. Lithium starts with 3 and ends with 1. So I need to put a 3 in front of the lithium product so that it's multiplied by 3 to equal 3. All right. Next, I'm going to look at calcium because that's my next metal. Calcium starts with 1, but it ends with 3. So calcium starts with 1, ends with 3. That's not balanced. I need to put a 3 in front of the calcium nitrate reactant so that calcium is multiplied by 3 to equal a total of 3. Okay, next up, I want to look at my polyatomic ions. And I can look at either one of them first. It doesn't really matter which one. I'm going to go ahead and look at nitrate. Okay, nitrate I underlined in green on both sides, and I'm going to label it down here in green. Now, nitrate has a 2 subscript on it, so 2 nitrates, but it also has a 3 out front. So look at where my little green dot is bouncing. Nitrate has a 2 times 3, that's 6. 6 nitrates to begin with. But how many did we end with? Nitrate on the other side only has 3. So what I need to do is replace that 3 with a 6. I'm literally going to erase it and up it to a 6. Now, what else did that do? That also now made my lithium 6. So I need to keep track that my lithium is now 6. And that means I need to get rid of this and make it 6. Well, to do that, I need to multiply by 2. So I'm going to put a 2 in front of the lithium. I'm going to get rid of that 4. That's confusing. That's just the problem number. And let's kind of study and make sure this worked out. 6 lithiums in my green bouncy dot. 6 lithiums with my green bouncy dot. Let's go back and look at nitrate. Nitrate is 3 times 2. That's 6 nitrates. Nitrate over here has a coefficient of 6. That's 6. Good. I don't think calcium has been affected, but let's double check. Calcium has 3 and 3, so calcium's still okay. So the one thing we haven't looked at yet, I'll look at it in blue, is phosphate. Phosphate is PO4. I'm going to use my green bouncy dot. PO4, that compound has a 2 in front of it, so there are 2 of them. On the product side, green bouncy dot, phosphate has a 2, so 2. So the phosphate worked itself out. This is now a balanced equation. All right, so I'm going to get rid of some of my little squiggly lines. We will circle in blue our full balanced double replacement reaction. Okay. Next up, we have Ag plus S. This is 2 elements, nothing else going on, just 2 elements. What could they possibly do? The only thing they can do is combine. So this is going to be a synthesis reaction. Okay, to put a metal and a nonmetal together, you write them together. But of course, that's not all. You still have to consider their charges and crisscross. So Ag has a charge of +1. It's often forgotten, but it is on your ion sheet. Sulfur has a charge of -2. So if I crisscross that -2 down, I'm going to have Ag2S. The final step would be to balance this chemical reaction. Ag starts with 1, ends with 2, so I need to put a 2 in front of my reactant silver. Sulfur is 1 and 1, so it's already balanced. So this is my balanced synthesis reaction for silver and sulfur. All right, that is the end of this. I hope it was helpful. If you have any questions, please come see your teacher. We are happy to help. Thanks for watching. Bye.